the other kind of battery that's common. Okay, we use them in hearing aids, you use them in anywhere where they want a very small battery, you'll tend to get one like this here. Our telescopes using hearing aids, a lot of optical devices. So anyway, these are 3 volt, if I remember right.
And it's 1.99.
Use them in these too.
Okay, yeah. Key fobs.
Yeah.
And the one in the hearing aids are much smaller yet.
You want to see one?
That's
Here's one from
a
here.
three-handed job,
We
isn't
put it
it?
on the other side of this, paper bag,
Yeah.
negative on this side.
Okay.
and the
Yeah, that's
positive.
all that was wrong. I can't look at this.
Yeah, that's what.
Well, it just makes sense to me that there'd be 2 of them that are bad right off the bat.
Operator error.
You should check.
Shut up, Murray. You can be replaced.
What's the difference?
It was 3 also. Well, actually, it's a little bit more than 3 if you want to do it. Let's see, you grab the red one.
Well, there are different things. If you're measuring milliamps, that's micro. This is ohms. How many ohms? This is megahertz.
So the red is always positive.
See, 110 electricity is 60 megahertz. So if you want to measure.
I have a question to ask.
110 is equal to 60 mega.
We're treating it with 60 cycles of the turn. That's the old turn. 110, 60 cycles.
Is it done?
Just a matter of interest, last 2 Saturdays ago at Harker Heights, the club there that we're part of, Makers Group, gave this at the library for kids. And it's called Play-Doh circuits. So they make circuits and check resistance and so on, all with Play-Doh. It's got a switch in it, so anybody wants to buy one, they're $20. I bought 2 for my grandkids because they were there. In the real world, not real world, the marketing world, commercial world, these are made by the people in Copper Cove. They're called squishy circuits. So you can buy the kits and so on. Anyway, well, this has got a motor in it, or a switch and a speaker. Here's an LED. And that number at the start there is how wide these are. You can get small ones, bigger ones, and so on. So most of the microelectronics, this number here, 5 millimeters.
Is the size of the bulb?
That's the size, bigger, smaller, so on, so. And on your LEDs, you have a long wire and a short wire. Okay? One's your cathode, one's your anode.
Whoa, back up. One is your what?
In electricity, you have plus and negative, cathode and anode. Plus and minus. basically.
Yeah, okay.
So, you're gonna measure it.
So how do you know which is what?
Well, you're gonna measure it with your thing.
One is long and one
You-
is short.
If you get a negative reading on a meter,
Meter.
it usually means it's going this way, okay?
Okay.
Usually get a positive reading, that's
How do
forward,
you-
voltage
Yeah.
forward.
Right.
If you, a motor, for example, if you want it to turn one way, you put you just take the positive there and switch it, the motor's gonna go the other way.
Right.
So if you're running
Yeah,
up
we
these
used to
little
do that.
cars, you want the wheel to turn one way, back up or
Right.
forward, you just have to switch it, so.
Yeah.
But anyway, what I want you to do is light it up.
You support the wrong guy. See, I have very little feeling in my hands, so.
polarized.
Yeah,
The reason it didn't light is
that's why the
polarity is
So the
important.
short is
So-
negative.
So the long one is the positive one,
There you go, you got it.
you know.
But that's an LED bulb.
A green one.
What do these things
So if you
cost?
buy any of these kits, so.
No, I said, what do they cost?
Oh, fuck. LED lights.
What's
what
the
are they
cost
called?
of one of those?
The
The
little
light.
ones.
Yeah, what
Oh,
do
five.
bag or
something.
$5-10, you can buy, probably buy 100 of them.
You know,
They
I
come in
save them
packs.
out of things I tear apart.
Oh, that's pretty, that's pretty.
But anyway, this is where now, if you put the 9-volt battery through there,
You burn it out.
you're gonna burn it out. However, if you put a 9-volt circuit through, you would do what?
Get a resistor.
You would put a resistor in,
Yes, sir.
just like an ohm's law here.
You have to reduce it.
Last week, Jack started, we're not gonna have time for it today, but these are the resistors.
Right. You put a resistor on
Was, I have a question on that.
Yeah.
You can put a resistor in, is there, everything usually has an opposite in nature, is there an
Well, your
opposite to
power
a
source in
resistor?
your RV is probably full. You'd have to get several resistors.
In terms of electrical components, I think you're talking, right? Yes, there's, at least in my mind, what the negative is a capacitor,
Okay.
okay? If you think about that like a,
Electricity, these things, you
the water tower we talked about, the thing out, if you put a balloon there, what's gonna happen? The balloon's gonna get bigger, bigger, bigger. It's gonna save that energy.
Yeah.
So instead of holding the energy back, it's gonna save it in the cell and then put it out.
Okay,
I'm
but
not
it
sure that's
doesn't
exactly.
increase it,
Card?
but it does not increase it.
I'll get it.
okay. I didn't see that. on my
I think
paper.
with a capacitor, it doesn't
Wouldn't increase the flow.
Yeah.
Yeah, yeah.
Well, again, let's get back to the balloon. If you fill it full of water, you take it off the faucet and let it go, what's gonna happen?
It's gonna
It's
deflate.
gonna go across the room.
Yeah. Yeah.
So, again, I'm not sure of the answer to the question, but you would have to measure it to see what it's gonna put out.
Okay, now here's another dumb question. You put a
In other words, the
resistor
current,
in.
the current, the flow, the push,
Yeah.
the pressure, whatever,
Yeah.
it's gonna be pretty strong.
Okay,
So
now,
I'm not
in,
sure, you'd have to put it in Ohm's law and do some measurements. I just
in
don't know.
hydraulics, if you go from a larger to a smaller pipe,
Right.
you're gonna increase the pressure in that pipe.